So in this section, we're going to look at proportions rather than means, and we're going to find confidence intervals for proportions. And notice our formula is now different. So let's look at example 7. We want to estimate the proportion of students at a large college who are female. A random sample of 120 students is selected. There are 69 female students in the sample, and we want to construct a 90% confidence interval for the proportion of all students at the college who are female. All right, so let's first open up let's start with our 90% confidence and get our z of alpha over 2. So exactly as we've done before, we're going to do 1 minus 0.9, which gives us 0.10. And then we want to take that and divide it by 2. So 0.1 divided by 2 is 0.05. And we're going to look up 0.05 in our Excel. So using the command equal norm.s.inv, let's put in 0.05. And that's going to kick back negative 1.645 or negative 1.64485 if we want to use the whole thing. I'm going to go back. So our z is going to be negative 1.645. All right, and now before we can do anything, our formula calls for p hat, and we get p hat by taking the number of women over the total number, and let me mark this as p hat. P hat is our 69 women out of 120 people, which gives us 0.575. All right, now let's go back here for a moment, and let's notice that we need to first check this interval right here and make sure that we have a big enough sample size, because if it's not large enough, we then really cannot do this confidence interval. So we need to do p hat minus 3 times the square root of p hat over 1 minus p hat over n, and then p hat plus that same quantity, and see if it lies in the interval 0, 1. So let's do that computation. We're going to have 0.575 minus 3 times the square root. We want p hat 0.575, 1 minus p hat divided by 120. All right, and if we do that, this ends up being 0.44, which is certainly between 0 and 1. And then we need to check the opposite computation. 0.5753 square root 0.575, 1 minus 0.75 divided by 120. And that ends up being 0.71. So both of those values are between 0 and 1, so we can go on with our confidence interval. So notice our confidence interval is now a little different. We're going to take p hat plus and minus the value we just got from our z of alpha over 2 times the square root of p hat 1 minus p hat over n. All right, so let's do that setup. So p hat is 0.575. We want plus and minus our 1.645, and we're going to take that and multiply it times the square root of 0.575, 1 minus 0.575 divided by 120. All right, so as I've done before, I'm going to do the entire right side of my plus and minus. So the 1.645 times the square root of 0.575 times 1.575 over 120. And when I put that into the calculator, I get 0.074. And so now we need to do our 0.75 minus 0.074 and our 0.75 plus 0.074. The minus gives us 0.501 and the plus gives us 0.649. So our confidence interval goes from 0.501 to 0.649. Now let's not forget though our confidence statement. We did 90% confidence, so we are 90% confident. Now this time, this was a proportion, so the true proportion of, and let's look back and see exactly what we were getting a proportion of. In this case, we're looking at the students who are female, so we want to write, we are 90% confident the true proportion of female students at this particular college is between 0.501 and 0.49. Now you could also make this confidence statement as a percentage, just saying we're 90% confident the true percentage of female students at this particular college is between 50.1% and 64.9%. You would just need to make sure that you converted the 0.501 and the 0.649 to a percentage, and that this was percent or percentage instead of proportion.